has, right, it's already recording. So the Euler's method, in Euler's method, derivative or at the beginning of the interval is assumed to be valid for across the entire interval. So for example, if we have this function and we wanted to find the value at x I plus 1. We wanted to find this yi plus 1. In order for us to find yi plus 1, we are going to use the slope that we have evaluated at the initial, at the interval. So this is the slope that I've mentioned. So in order for us to extrapolate to yi plus 1, we are going to use the slope that we determine at the beginning of the interval to get that value. However, actually, so this is the value of yi plus 1 using Euler's method. So as you can see, we got a large error, not really, you cannot really see whether it's a large error or not on this graphical and on this graph. However, if you try to calculate the global error, you will see that Euler's method has the biggest global error for that particular step. So in order for us to improve our answer, I think someone is waiting for me to, okay. So in order for us to improve our answer for using ODE method, numerical method, the first one would be using HEUN'S method, and the second one would be the midpoint or improved polygon method. So these two are actually derived from Euler's method. So that's why we call it as improvements of Euler's method. Next week, we are going to learn a much higher order Runge-Kutta method, where instead of using Euler's method as the prerequisite, we are going to see that it actually is quite different from Euler's method. However, the formula, where the generic formula of ODE, which is I plus 1, yi subscript I plus 1 equals to I plus, is still valid. The only difference would be how you calculate the slope here. Now, for HEUN'S method, this method is used to improve the estimates, where for HEUN'S method, we are going to determine the derivative for the interval. So instead of having only one derivative, we are going to determine two derivatives at different points in that particular function. So the first slope would be determined at the initial point, and the second slope would be determined at the end point. So if we try to draw that, oops. If we try to draw that, we will get something like this. Yeah, this. So let's say that we have so this is the function that we wanted to the ODE function that we wanted to solve, and this is the value of xi, and this is xi plus 1. So you wanted to know what is the value of yi plus 1. So first, we are going to determine the derivative at the initial point. So this is the derivative at the initial point, and also the derivative at the end point. So we are going to see that, so first we are going to see the first derivative should be like something like this, and then the slope. So we are going to have two slopes, and then these two derivatives are then averaged. So for example, if we have this is f1 prime and f2 prime. So prime means it's a slope, the derivative. So in order for us to find the average derivative, so we put it as f prime here. It will be f1 prime plus f2 prime divided by 2. So after we obtain that particular average slope, we are going to use that to estimate the value of I plus 1. So I'm going to show you in detail, because this is only a rough idea of how we are going to use HEUN'S method. So as I mentioned before, first we are going to determine the slope at the beginning of the interval using the Euler's, using the function itself. So this is, for example, if we have a function here of x, and this is yi. So we are going to so this would be the slope here. So the slope here is actually yi prime equals to yf, the function. So we just substitute the value at xi and yi into the equation, into fx, to get y prime I. So this would be our first step. Our second step is then, using the Euler's method, we are going to extrapolate linearly to yi plus 1. So we are going to extrapolate this linearly to, so this is, if we y so x plus 1, so this is the value. So if we try to extrapolate linearly, we'll get the value here. So this is the value of y superscript naught I plus 1 equals to y I plus f xi yi h. H here is the step size. So this is actually step number 2. So this equation we call as predictor equation. So predictor equation, it going to predict the value of y superscript naught I plus 1 in using the value that we determine at the beginning of the interval, the slope at the beginning of the interval. And after we have obtained this, the value of yi plus 1, the yi prime, the y superscript naught I plus 1, we are going to use that value to estimate at the slope at the end of the interval. So we are going to find this slope. It might be It's not supposed to be a straight line. So this would be step number 3. So step number 3, y prime I plus 1. So this is y prime I plus 1. And using the value that we obtain here, the value that we get from here, so we just substitute to this value. And therefore, the average slope of the interval is actually y bar prime I equals to the slope at the initial point and the slope at the end point, and we average it by 2, divided by 2, and then we are going to use that slope, the average slope, to extrapolate linearly from yi to yi plus 1. So at the end, we are going to see that this is the new slope. So this new slope is actually the slope for the average slope. So this is step number 4. So step number 4, we are going to use that average slope to get to extrapolate linearly from yi to yi plus 1. And this equation we call as corrector equation. Euler's method, since it has 2 predictor on corrector approach, as you can see here, it's actually a predictor corrector approach. We actually can do an iterative calculation using a predictor and corrector. So this is Euler's method. So since it's an iterative fashion or repeatedly to get an improved estimation of yi plus 1, therefore we can actually use similarly with the previous calculation lecture, we can actually use the stopping criterion. So the stopping criterion here is using the relative error. But in this particular course, we are not going to use iteration for Euler's method. We are going to assume that we're only going to use predictor and corrector once. So you do not need to iterate the calculation. So this is Euler's method. In order for you to understand, in order for ensure that you understand this, can you try to do this? I'm not sure why does it come out like this. Okay. So this is example number 2. Use Euler's method to integrate the equation below from 0 to x equals to 0 to x equals to 4 with a step size of 1 and iteration of 1. So what we are going to do is would be around 4, and h is equals to 1. So iteration of 1, meaning that we're not going to have a multi iteration. We are going to stick only to 1 step of corrector and also 1 step of predictor equation. And it says that at the initial condition is 2. And also I would like to add here, using analytical analysis, y can be solved using this. So this would be the analytical solution for the ODE. Right. Can you try? I'm going to give you about 5 minutes for you to have a look, and let's see if you can just use the HEUN'S method that we have learned in order to find the value of yi plus 1. So the first thing that you need to do is to draw a table, similarly with with example number 1. Oops. Some of you might ask me, how do you get the value of 0, 1, 2, 3, and 4? This value, actually, we get it from the value of H, step size. So this would be the increment of the step size. Since in the question itself, it mentioned that at x is equals to 0, y is equals to 2. So we are going to assume that the function will start from 0. So this would be the start at the beginning, the initial point of x. So that's why we start with 0. And then we are going to increase the value of x according to the step size. So the step size here is 1. Therefore, we are going to increase the value of x in the increment of 1. So this is h equals to 1. So here we add h at h at h. So it depends actually on the value of h. So for example, if you have h as 0.5, therefore we are going to have an increment of 0.5. So it will start from 0, 0, 0.5, 1, 1.5, and so on. So you have to be careful. Please do not assume that the step size would equals to 1. You have to refer to the question itself. So we are going to have this table. The first one we're going to do to have this table. And what we are going to do is, since it's already been mentioned that for x equals to 0, y would be equals to 2. So we're going to add into the value, so this would be 2. And if you substitute the value of 0 into this equation, I presume you will get also, you can try, I presume that you will also get 2. And then the global error, remember that the global error is actually the modulus of the value of the true value of y minus the HEUN'S value of y divided by the true value of y to get the times 100%. So in this case, it would be equals to 0. So which means that it's similar to the value of the true y value. For the second step, which is at x equals to 1, am I mute or can you hear me? Because I'm quite worried that I'm talking to myself.
Yes, we can hear you, Doctor.
Okay, thank you. So at x equals to 1, y plus 1. So in this case, I plus 1 here, since I is 0 plus, I plus 1, 1, 0 plus 1 is 1. So it's actually 1. So this is superscript naught. Just make it bigger. Superscript naught 1 is actually, if you refer back to the equation, is 0 plus f 0 and 2. So this corresponds to xi and yi. So yi, xi here, this is xi for 1, and this is yi for HEUN'S. And then the step size is 1. So if you try to substitute the value, which is 2 plus, so we just substitute into this equation, original 4. So this would be 0.8 minus 0.52. We actually will get 5. And then we are going to get the slope at this initial point. So this would be from the equation itself, where we are going to find the slope. So for the slope at 1 would be 1 point, we just substitute into the value of 1 and 5 into this equation, the original, the function itself that we wanted to solve, and we will get 6.40216. And then since we already have the two slopes, so this is the slope at the end of the the interval. So we are going to average that to get a value of yi. So oops, it's equals two. So this is actually and you will get 6 point. So this would be your value for HEUN'S 6. And if we try to substitute the value of 1 into the analytical analysis, the true equation, we will get the value as 6.19463, and the global error we can calculate as modulus divided by 619,463 times 100%. You will get 8.2%. So this would be 8.2. Right. In order to ensure that you understand what I'm doing, I'm going to do another step. So this is a bit straightforward. So at x equals to 2, so if we try to substitute everything, we will get 12.2527. So please remember that to keep to 6 significant digits. So you just substitute this value into the function to be solved. and you will get 13.6858, and the value at 2, x equals to 2 would be h equals to 1 would be 16.3198. So if we try to substitute this into, this would be here, 16.3198, while the true value is 14.8439. So the global error would be 9.9%. Right. Can you try to do x equals to 3 and x equals to 4? I'm going to give you about 10 minutes for you to do it. Thank you. While doing that, you can ask any question if you don't understand. Any question? No? So if you don't have...
Doctor?
Yes.
Can I know for the analytical analysis, the
Yes.
E power 0.8, and then what is
It's
after that?
oh, sorry, it would be x. This would be x.
All right, thank you.
Okay, welcome. Right, can you try to do x equals to 3 and x equals to 4? Because later on we're going to have another methods. The reason why I take this particular MATLAB session, because I don't want you to get confused between all these Rankata's method. So can you try to do x equals to 3 and x equals to 4? Right. Have anyone tried to do x equals to 3? Anyone? No? That's right. Fatin? Hafizi? Not yet? If you have any problem, you
Not
may
yet.
ask me, yeah? Hafizi, have you done? Not yet?
Not yet, not yet.
Not yet. Aida? Oh, who else? Just wondering, can you access the attendance now? Irfan? Have you filled in the attendance?
Yes, yes, Doctor.
Yes, okay. This is the reason why I don't like to ask question in class, because if I ask question in class, suddenly a lot of you will exit the Google Meet session. This is also similar this is also happening during my last semester, your seniors. So I hope if you're still working on it, please just let me know. No need for you to go to exit the Google Meet. I'm not going to get angry or scold you. If you have any problem, you just let me know. Okay, so I'm going to show that. Okay. I know that it's a bit tricky for you to apprehend, to understand, but I hope that after you go back, you will try to do this. And then just to let you know that your test next week will stop until last lecture, which would be, if I'm not mistaken, that would be on numerical integration, Simpson one-third rule, and also Simpson 3/8 rule, Newton cotes integration. So that the test only cover up until that. The test not going to cover this week onwards. So please make sure that you study up until the numerical integration only. Now I will just put the answer so you can check whether you have done the correct, you get the correct answer or not. So at 3, Euhn's is 37.1992. True is 6772, where the global error is 10.5. Euhn's is 83.3378, 75.3390, and the global error is 10.6. So as you can see that the global error increase as the step size as we increase the value of x. This is due to the truncation error. So as we move, if you have error here, if the error is at 0.2, it will be propagated as we move on in the next step. So if you already have a wrong answer here or not that accurate answer, it will be propagated. So the total of this propagation and also the truncation error would equals to the global error. So that's why it's keep increasing. If your global error suddenly decreasing, there is something wrong with your answer. So you have to make sure that the global error, at least you will see an increasing trend. So later on, can you please try to check your answer? Okay, so this would be for Euhn's method. So the next method that we are going to learn would be the midpoint method. So this method is also known as improved polygon method or the modified Euler's method. So it uses Euler's method to predict a value of y at the midpoint of an interval. So previously, Euler's method, we only have one slope, and that slope is going to be used to extrapolate the value of yi plus 1. Only one slope, that's for Euler's method. For Euhn's method, we're going to have two slopes, and these two slopes at the initial and also at the end of the function of the interval will be then averaged to get the slope for the entire interval. And for midpoint method, what happened is that we are going to predict the value of yi plus 1 using the slope at the middle of the interval. So if let's say that we have, so I'm just going to use this. So first, what happened is that we are going to use Euler's method to predict a value of y at the midpoint of the interval. So this is the midpoint of the interval, xi plus half. So this is midpoint. So from what happened is that here, the slope here at the initial of the interval, we're going to use it to extrapolate to get the value at yi plus half. So after we obtain the value of yi plus half, we are going to use that value and substitute it into the original equation, y prime, to get the slope. So first, what happened is we are going to get the value of the midpoint of the interval, the y value. And later, we are going to use this predicted value to calculate the slope at the midpoint. So this is step number 1. This is step number 2. So step number 2, we are going to get y prime, which is the slope at the midpoint. So this is a bit tricky. In my experience, most of your senior have problem in this particular method because the prediction or in the middle of the interval. So this is the values of yi plus half and yi plus half. Substitute the value into the original equation, and then we are going to use the value that the slope that we already evaluated in the middle of the interval as a valid approximation of the slope for the entire interval. So we are going to use the slope that we obtained in step 2 for the entire interval from xi until xi plus 1. So this one be so there are 3 steps here, 3 main steps. And example number 3, it needs you to solve the following ODE using midpoint method over the interval from 0 to 2 with a step size of 0.5, and the initial condition is y equals to at x equals to 0 is y equals to 1. So this is example number 3, but in this particular case, I would like to compare with the previous example. So this is for your homework later on. What have I wanted to use this. So I just copy this one. We are going to use example 2, and instead of using HEUN'S law, we are going to use midpoint. I'm going to delete So we are going to use the similar function that we have done in example 2. For example 3, you can try to do it yourself at home. So we are going to try to do example 2 using midpoint method. So this one is actually midpoint method. Oops. So just, this would be midpoint. So midpoint, this one should be 2 because of this, and true, the global error is 0. Now, first what we are going to do, am I mute or can you hear me?
We hear you.
Okay, thank you. Okay, so at x equals to 1, so using the equation previously, this equation, I'm going to use this 3 equation. So at x equals to 1, so this is step number 1. So this is the slope. Sorry, so should be. Size is 0.5. So if you refer back to the h here, would be divided by 2. So since we have h equals to 1 divided by 2, it will equal to 0.5. So this is 2 from this value here. 2 plus, so you just substitute 0.2 and 0. So this is not 0.2, this is 0. This is F0 and 2, 0.5. So 2 plus, so you just substitute. So 0.8 times x, so x here is 0, minus 0.y, this, so I'm referring to this equation, times y, so y here is 2, times 0.5, so it would be, oops, what happened here? So it would be equals to 3.5. What is the point here? And then the second step is to find the slope at the middle of the interval using the value that we obtained here. So F 0.5, which is the middle of interval, 3.5. So this actually corresponds to X and Y. So we just substitute this value into the original equation and you will get you'll get 4.21730. As usual, keep it to the 4 or 6 significant digits. And then the third step would be to find the value to extrapolate the value of yi plus 1, which is in this case is y1, using the slope that we estimate in the middle of the interval. So y0 plus, so this is the slope that we already calculated. So y here is, so this is x and y. And you will get 6.21730. So this would be 6.21730. And y true, if we try to substitute 1 into this analytical analysis, we will get 6.19463. And if we try to calculate the global error, we will get 0.7%. So if you try to compare it with HEUN'S method, the global error for the x equals to 1, it's actually lower for midpoint method compared to HEUN'S method. So in a way that this actually correspond to the degree of accuracy for Euler's method, HEUN'S method, and also midpoint method. So if you remember in the previous lecture, I have mentioned that Euler's method, HEUN'S method, and also midpoint method, the accuracy will keep increasing as we move on from your Euler's, HEUN'S, and midpoint. So midpoint method would be the most accurate compared to these two. So that's why I wanted to do the example 2, so that we can see the global error for midpoint is actually lower, much lower compared to HEUN'S and also Euler's method. So for x, so this is x equals to 1. So at x equals to 2. So I'm just going to do this straightforward. So this is, so this is actually correspond to I plus half, y subscript I plus half. So half here is actually 0.5, half from the value of h. So this is, oops. And you will get, if you try to substitute into the original equation, you will get 9.114057. And this is for the first equation. The second equation, by referring to this, the second equation would be the determination of the slope at the middle of the interval. Oops, sorry. So this is 1.5, 1.11. So we just substitute the value into the original equation. 72344, and y2 is actually y1 plus the interval, the slope at the middle of the interval. So remember, in order for at the beginning, at step number 1, the h value is half. However, at the end, at step 3, we are going to use the h value, which is 1. So if we try to substitute it, it would be equals to 14.9407. So this would be the value for the midpoint, 9407, and 14.8439. And if we try to calculate the global error, it would be equals to 0.7, nearly 0.6. So as you can see that the global error for midpoint method seems to be static or decreasing. It's due to the fact that its accuracy is quite higher compared to HEUN'S and also Euler's method. So this is for x equals to 1 and x equals to 2. Can you try to do this for x equals to 3 and x equals to 4? I'm going to give you about 10 minutes. And then later on, we're going to discuss about your tests. Okay, so this is 11 past 10. So I'm going to give you up until 10:15. And after 10:15, we're going to discuss about your tests. And also, I'm going to give you a mock test for you to prepare yourself for the test next week. So I'm going to give you 10 minutes to 15 minutes, 10 minutes. So it would be 10:20. Okay. Any question before that? No? Any question regarding the midpoint method? If no, I think we better move on. Right. Next week we are going to still dwelling on ODE. However, we are going to venture into a higher order Rangka Kata, which is a bit similar to what we have learned in this week, but in different manner. But I don't want you to get confused, so that's why the Euler's method, HEUN'S method, and Midpoint's method, I have I already teach you in this within this week. However, next week on Wednesday, I'm going to teach you on the higher order Rangka Kata's method. Now, the entire screen. For your test, it would be on Friday next week. So it will be 2 hours. And also it would be on the 7th. So please make note of that. It would be on the 7th of May. Sorry, this should be May. But this is just a mock test. So this is a mock test, something that you will encounter in your test next week. So this would be the instruction. So you have to answer all questions. This is an open book examination, and you have to use MATLAB and hand calculation to solve this test. And also you have to compile your answers via Spectrum. I will provide a link later on, a submission link for you to submit your answers. And then the closing time is at 11:15 a.m. So I'm going to give you about 15 minutes for you to compile everything. So your test would be from 9 o'clock until 11 o'clock, and 15 minutes for you to compile everything into a PDF file. And the marks will be deducted for late submission. And also please remember to use 6 significant digits to present your answer. There will be 2 questions. However, there will be several sub-questions for one question. So for example, question number 1, in this particular question, I'm going to ask you to do bisection to find the roots of this equation using bisection and also false position with a given stopping criterion. So this is just an example. For this particular mock test, please be aware that I will not give you the answer. You have to find it yourself and compare it with your friends. So you have to do this using both hand calculation and also MATLAB. So there will be 2 sections. For example, question 1, A, there will be 2 answers using hand calculation, and also the second one would be using MATLAB. Similarly with B, hand calculation and also using MATLAB. Another thing that I would like to emphasize would be the methods and also the question. The question would be a bit similar. This particular mock test is only to give you a test of what you will encounter during your test. It would not give you the exact question. Therefore, you have to keep in mind that in order for you to answer your test, you have to do it in 2 sections. One, hand calculation, and also the second one using MATLAB. So please try to keep this in mind. And then your hand calculation, you have, and also your MATLAB, you have to compile it into PDF. in one single PDF. So that's why I'm giving you about 15 minutes for you to compile everything. So for MATLAB, please include the answers that that you get in the command window along with the M file. So you have to copy paste the M file and also the answer that you get from the command window, not only the M file. So you have to give me the answer also. So this would be question 1. Question 2 would be to solve a given equation using naive Gauss elimination. So this one, you also need to use both hand calculation and also MATLAB. And this would be the integration, numerical integration, single application. So every time I ask you to do single application, multi-application, single application meaning that the only one segment. If it's multi-application, it will depend on the segment that given. For example, if I mention that it would have 2 application or dual application of Simpson-Wanted rules. So it means that the number of segment would be 2. So you have to be careful. So single application meaning that you are going to only have 1 segment and so on. So this would be your test. Please make sure that you run through all the page number. For example, please check the page number, because not some, but only one of your seniors in the previous year, he thought that the question only have 2 pages, but he forgot to read this part. This actually mentioned that it in that particular, because he followed directly the mock test. He didn't really read the instruction carefully, so he only thought that only 2 pages, so he didn't go to the 3rd pages, so he already lose about 10 marks there. So please make sure that you run through all the pages. And this would be, I'm going to give this post it on Spectrum and try to do this during the weekends and compare this with the answer between hand calculation and also your MATLAB calculation. I will not give the answers. You have to discuss this with your other friends, or maybe you can compare it with your MATLAB. So if let's say that the value is a bit similar, therefore you can confirm your answer as the correct one. So this is for your test. And for your test next week, I wouldn't be in the test as I will be presenting in the faculty meeting for our department's curriculum review. So Mr. Shevan will be the only one who will be invigilating you. During the examination, it will be recorded, and please make sure that you open your camera. So you have to switch on your camera, but you do not need to switch on your microphone, only your camera. So please make sure that you have a good camera and also a good connection, internet connection. Yeah, I hope not, I'm not, oh, okay, that's good. Any question regarding the test? We are going to finish a little bit early today. Any question before we finish? We stop the class. I'm going to stop recording.